Hey, welcome back, scholars. We are doing our lesson 4.5, right triangle congruence. And then after that, we have a little extra fun stuff for you, but I'm not going to ruin the surprise. I'm just kidding. It's not fun. It's just more math. Okay, so let's do a review from our last classes. We found out that there's 4 ways to prove that triangles are congruent. And that is side, side, side. That's when you have 3 congruent sides in 2 triangles. See, 3 congruent sides. Side, angle, side. Angle, side, angle. And angle, angle, side. Now I haven't mentioned this to you, and I'm just going to make a note of this. Don't forget this. These are the ways you can prove that angles are congruent. Triangles are congruent. The ways you cannot do it, though, all right? You cannot prove it by AAA, angle, 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 and angle, side, side. These 2 ways you cannot prove congruence. Cannot prove. It's just a little note. Cannot prove congruence. Congruence. And the way my math teacher used to tell me is that there's no ass in math. That's a good one. All right, so remember, if you ever have ASS or AAA, you cannot prove congruence that way. All right. Now, the last way we're going to learn about proving congruence, though, in addition to those 4, is hypotenuse leg. And hypotenuse leg is this. 2 triangles are congruent, if they both have right angles, all right, a congruent leg, and a congruent hypotenuse, all right, hypotenuse. So if you have 2 triangles that have a right angle, like we see right here, these both have a right angle, a congruent leg, which you see right here, and a congruent hypotenuse, then you know the triangles are congruent. So in this case, we have those 3 conditions. They are right angles, they both have a congruent leg, and they both have a congruent hypotenuse. So these 2 triangles are congruent. Now, just as a quick reminder, hypotenuse is always the longest side in a right triangle. Okay, it's the longest side. That's always what the hypotenuse has to be. And the leg is one of the shorter sides. All right, so let's do a little practice with that. State if the following triangles are congruent. If so, how do we know? Well, let's take a look at this one. First, do they have right triangles? Yes. Okay, so they both have a right triangle. I see that right there, okay? They're both right angles. Do they have a congruent leg? Well, right here, I see congruent leg in both of them. And do they have a congruent hypotenuse? And this ZY and CB, those are both the hypotenuses. They are congruent, so these would be congruent because of hypotenuse leg. So I would say triangle CBA is congruent to triangle ZYX because hypotenuse leg, and we just use HL. Now let's look at these 2 triangles, okay? Well, I do have a leg that is congruent, all right? I do have a hypotenuse that is congruent, but these are not 90-degree triangles. They are congruent, but they are not 90 degrees. So there is not enough info to prove that these are congruent. They might be, but there's not enough information. Furthermore, if you remember, I just said that you cannot use side-side angle to prove it. This would be a side, this would be a side, this would be an angle. This would be a side, this would be a side, this would be an angle. You cannot prove congruence using ass. Sorry, that makes me laugh every time. Finally, what additional information is needed to prove that the triangles below are congruent using hypotenuse leg? Well, let's look what we got. In this case, I have a right triangle. All right, they're both got these right angles, so that's covered. They both have a leg that's congruent, but they're missing a hypotenuse. And the hypotenuse is the longest side, which would be in this case UT, and in this case FG. So if UT was congruent to FG, all right, then I know that these 2 would be congruent. In this case, I have a leg that's congruent in both of them. I have a hypotenuse that's congruent in both of them, but I don't have the right triangle, so I have to add a little right triangle in there. So if I saw that angle B was equal to 90 and angle H was equal to 90, then I can prove that these 2 triangles are congruent using hypotenuse leg. Woo! Okay, you ready for the fun stuff now? It's about to get real. Now, before we get started, you need to remember these 2 facts. One, vertical angles are always and I want to emphasize always, congruence, all right? They are just congruent every single time. And shared sides, so sorry, let's go back to this. These two are vertical angles. I know these two angles are congruent. Now, when two triangles share a side, okay, so like I have a triangle here and I have a triangle here, and they share a side. When they have a shared side, the shared side is congruent. All right? This side right here, let's call it BD. BD is congruent to itself. So they both have the same side. I know that it's congruent. I put a little mark here saying that both triangles have a congruent side because they share the same exact side, which makes sense, right? Anything is congruent to itself right here. Okay, so what I'm going to do is prove that these triangles are congruent, but what you have to do here is mark either if they're vertical angles, right, or they have a shared side first. So what do I mean by that? So in this case, I have these two triangles, and I want to prove that they're congruent. The way I'm going to do it, though, is since they share a side, I can add another congruent side to both of them, right? This shared side is always congruent. So now I have a side that's congruent on both of them, right? This side is congruent to this side. I have another side that's congruent. This side is congruent to this side. And I have a third side that's congruent. It's that share side. So what I have here is they are congruent because of side, side, side. So we had to add in that information ourselves. Now let's look at this one. I have two triangles here, right? I got this triangle and I got this triangle. And I'm trying to prove that they are congruent. But there doesn't seem to be enough information. But what I said is that you have to mark these first. Now looking at this, I see that there's a vertical angle right here, right? So these two are vertical, so I know they're congruent. I can mark them myself. Vertical angles are always congruent. Because I know they're congruent, I now can prove that these two are congruent, triangles, right? Because I have side, angle, side, and side, angle, side. So yes, these are congruent because of side, angle, side. All right? Once again, if you look at this guy, I have a shared side in this one. They both share this side right here. Because they both share a side, I could say that this is congruent to each other. And then I can prove that these two triangles are congruent because they both have a 90-degree angle, they both have a congruent leg, and they both have congruent hypotenuse. So this would be, yes, they're congruent because of hypotenuse, leg. And let me just outline this again for you guys. That's my first triangle, one leg and hypotenuse in a 90-degree triangle. And this is my second triangle, 90-degree triangle, hypotenuse, and leg. Done. All right, let's keep going. Over mirror. All right, if you look over here, I have another pair of vertical angles. So the first thing I'm going to do is mark that they're congruent. These two vertical angles are congruent. So then looking at these two triangles, what kind of congruence do I have? Well, it seems that I have angle, side, angle. The side is between the two angles, right? I have my side between, in between. So because I have angle, side, angle, I have two congruent triangles because of angle, side, angle. Now I couldn't have proven that if I didn't mark that these vertical angles are congruent first. This guy, okay, it shares a side again. So I'm going to mark that the side is the same. All right, let's just mark that side. So I have my two triangles here. This is my first triangle, all right, right over here. And I have my second triangle right over here, okay? Now if we look at them, I have two congruent angles. I have a congruent angle here and a congruent angle here. These two triangle angles are congruent. I have another angle that's congruent both of them, and I have this side that's congruent. Now the side isn't between the two angles, so I would say that they are congruent because of angle, angle, side. Remember, the side is not between the two angles. And finally, I have this third example. Well, there's vertical angles right here. Let's mark that they're congruent. These two vertical angles are congruent. And if you look here, I have angle and two sides that are congruent, but the angle is not between the two sides. So this would be angle, side, side, angle, side, side, which remember is not possible because there's no ass in math. That's funny. There's also no SSA, okay? ASS and SSA are the same thing, just in case you were wondering. Okay, now we're going to get to the difficult stuff. You ready for it? I am. All right, so we got to do two things. One, we got to mark the picture with the given information, all right, to prove that these triangles are congruent. And we also have to use what we just learned about vertical angles and shared sides. So, you know what, let's just get into it. All right, first thing we do, we're going to mark with the given information. Now, you guys should be pros at this because we did this all in the first unit. So first thing is AE is congruent to DE, all right? We also know that BE is congruent to CE. And then finally, even though this isn't in the given information, we see that there's vertical angles right here, all right? See that? Now, because we're trying to prove that these two triangles are congruent, and which two triangles? Let's outline them clearly for you. I'm going to use a nice little highlighter. We got triangle 1 right here, right? AEB. And triangle 2 over here, ECD. All right, we're going to prove that these two are the same using what? Well, we have two sides with the angle in between, two congruent sides with the angle in between. This would be side angle side. So, I prove that Okay, that triangle AEB is congruent to triangle DEC because of side angle side congruence. Okay, so we're going to do once again the same thing. We're going to mark with the given information and try to prove that these two triangles are congruent. We're trying to prove that WXV is congruent to ZXY. All right, so the first thing we know is that angle V is congruent to angle Z. Furthermore, we know that WY bisects VZ. And what's bisect mean again? It means to cut in two congruent pieces, right? It cuts in half, two congruent halves. All right? That's what our bisect means. So WY bisects VZ, right? So VC just got cut in half, so this is congruent to this, right? It just got cut in half here. Finally, we know that these are vertical angles, so I'm going to mark that they are congruent. So we got this angle is congruent to this because they're vertical. And now we're trying to prove that our two triangles are congruent. This triangle is congruent to this triangle. And if you look here, we have angle side angle, and here we have angle side angle. So we've just proven that triangle WXV is congruent to triangle YXZ. Remember, the order does matter. Don't just write this randomly. Because of angle side angle congruence. All right, a little crazy, right? You have to mark everything that's given. So, in this case, BA is congruent to BC. So, BA is congruent to BC. D is the midpoint of AC. And remember, midpoint just means cuts into two congruent pieces again, right? Because this is in the middle. So I know this is congruent to this. D is in the middle of AC. Remember when we used to do that in Unit 1? Cuts it right in half. Okay? So AD is congruent to DC. And finally, since there's a shared side right here, we know the shared side's the same. So I want to prove that these two triangles are congruent. That means I know that I have three congruent sides in both of them. 1, 2, 3. 1, 2, 3. So triangle ABD is congruent to triangle CBD because of side, side, side. AB is congruent to BC, AD is congruent to DC, and BD is congruent to itself. That is three congruent sides. All right, this one's a doozy, so let's give it a shot. DB is perpendicular to AC. Now, what is perpendicular? Okay, perpendicular. That's what this symbol means right there, that little T-looking thing. DB is perpendicular to AC. And what that means is that it intersects to create 90-degree angles. So this and this are 90 degrees. Second part, DB is the bisector of CDA. That is this angle right here. All right? It is the bisector. So that means it cuts into two congruent halves. So if I cut this in two congruent halves, I've just created that this angle right here, okay, CDB is congruent to this angle. Oh. Now if you're looking at this, there's one other thing I could have. DB is here and it shares the side, so I know this side is congruent to itself. So looking at this, you'll see that since these two are 90, they're congruent. So angle CBD is congruent to ABD, so that's one congruent angle. I know that this angle is congruent to this angle because of angle bisectors. DB cut in half into two congruent halves. And I know that shares a side, so that middle side is congruent, so I have angle, side, angle congruence. So CDB is congruent. Triangle CBD is congruent to triangle ADB because of angle, side, angle. All right, guys, this does get a little complicated. Don't think I'm not aware of that. So as long as you're marking, all right, your pictures with all your information and just trying to remember which kind of congruence you prove, you will do just fine. Do not forget what a bisector is. Go review your notes or a midpoint that it cuts these things in half, okay? That will help you out so much in this unit. That is actually my only word to advice. And don't buy the iPhone 6 because guess what? They're not as cheap as you'd think. I just found that out the hard way. Peace.